Welcome viewers. In this video we'll see the introduction about stepper motor. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Stepper motor, introduction, definitions, application and types. First we'll see the stepper motor. Stepper motor is an electromechanical device which activates a train of steps movement of shaft in response to the train of input pulses. We know that in generally the motor is a electromechanical device. It will rotate continuously. When the electrical energy is given, this is converted into mechanical energy, rotation. But that is continuous rotation. But this stepper motor is not a continuous rotation motor. It will move in a step-by-step movement. When the pulses are given, when the input pulses are given, it will move step by step. The supply is not given continuously. When the pulse is given, it will rotate. Each pulse moves the shaft through a fixed angle. So these pulses are designed in such a way that it will rotate in a particular angle. So this angle is decided by the pulses. So the continuous supply is not given. Pulses are given that will make the rotation in a particular fixed angle. The angle through which the motor rotates or shaft move for each pulse is known as step angle, beta. It is given as a step angle beta expressed in degrees. So this beta depends upon the definition of beta, depends upon the number of poles in stator and rotor. That will see the definition. So stepper motor is a electromechanical device converting electrical energy into mechanical energy, but not a continuous movement. Based on the train of pulses, it will move in a particular angle, fixed angle. The angle at which it is moving is called a step angle, called beta, expressed in terms of degrees. That depends upon our requirement. We can design the pulses based on this step angle. Now we'll see the definition for step angle. So let us consider N is the number of rotor poles. Ns is the number of stator poles. M is the number of pulses. Right? So this NR. NR means number of rotor poles. Ns number of stator poles. Number of pulses. The step angle beta equal to 360 degree divided by M into NR. M is nothing but number of pulses. NR is the number of poles in the rotor. Another definition is difference between stator and rotor poles. Ns, difference of Ns and NR divided by Ns into NR into 360 degree. That is the another definition. Either we can use. So here number of stator poles and number of rotor poles available. Here number of pulses are available. M into NR. So based on this you can decide the step angle. This Ns and NR is almost fixed during the construction itself. Number of stator poles, number of rotor poles. So this M will decide the step angle. Number of pulses we can decide. So during this construction itself, this is a based on the operation, based on the excitation, based on the pulses, we can get the different step angles. Now we'll see how we are getting the different step angles. The stator and rotor poles are almost fixed. Based on the operational method, we can get the different step angle. The smaller the step angle, greater the number of steps per revolution and higher resolution or accuracy of position obtained. So in order to get the accuracy, resolution or accuracy or resolution or revolution, we need smaller step angle. So while moving in smaller step angle, we can get the more resolution. The step angle can be small as 0.72. So minimum step angle we can get 0.72 degree at the maximum of 90 degree. The common step angles are 1.8 degree, 2.5 degree, 7.5 degree, 15 degree. So these are all the common things. So based on the operation of the excitation of coils, we will get the different step angles. Now we'll see the another definition, resolution. What is meant by resolution? So resolution is given by the number of steps needed to complete one revolution of rotor shaft. So in order to complete one entire rotor revolution, how many steps are needed? That is called a resolution. Higher the resolution, greater the accuracy of position. So the resolution is more mean we are getting accuracy of position. So how it is defined? Number of steps divided by revolution. 360 degree divided by beta. That will give the resolution. Right? So for example, complete one revolution 360 degree. There are 100 steps are needed, mean we will get more resolution. Only 10 steps are means within 10 steps it complete one result, the resolution is less. The degree is more and resolution is less. Right? If more number of steps mean it will rotating in a smaller angle, so that will get the more resolution. Then another one is motor shaft speed N. Motor shaft speed N is there. Operation of stepper motor at higher speed is called a slewing. If F is the stepping frequency or pulse rate in pulse per second, then beta is the step angle. Then motor shaft speed is given as beta into F divided by 360 degree RPS, revolution per second. Right. So this is given as speed. Normally in the motor we have the speed is available. N is given as N, revolution per minute or revolution per second. That is based on 120 F by P, based on the frequency and number of pulses. Similarly here, this motor shaft speed is based on step angle, frequency, the frequency of the pulse, stepping frequency or the pulse rate, that will decide, divided by 360 degree. That will give the shaft speed. When stepping rate is increased quickly, the motor loses synchronism and stops. So the stepping rate should be in a proper way. So we should not increase quickly. Slowly we need to increase or slowly we need to decrease. Then only we'll get the synchronism. Otherwise it will loses the synchronism and the motor will stop. Then finally we'll see the applications and advantages. Application and advantages. The first one, used for operational control in computer peripherals, textile industry, IC fabrication, robotics, etc. That is in computer peripheral mean printer. While printing, we need to print the one line, thereafter need to go to the next line. So after printing one line, we need to move a particular angle. Similarly, while printing the one line, each letter we need to move in a particular angle. So for printing the line also, we need the stepping angle. After completing one line, we'll go to the next line. There also one stepping angle is needed. Similarly, robotics, movement of the arm, movement of leg, moving right side, left side, everything is controlled by the stepper motor. Similarly, textile industry, a step-by-step movement is needed. It is also used in typewriters, very similar to printer, typewriters, line printers, tab drivers, floppy disk, CNC machine, XY plotters. So in all these applications, there is a step-by-step movement is there in typewriter also. While writing each letter, it will move to the next position. After completing one line, it will go to the next line. Therefore, that we need one more stepper motor. Similarly, line printer, CNC machine, it is completely of step-by-step movement is needed. Forward, reverse, right side, left side, forward rotation, reverse rotation, all are needed. Then it is also used in commercial, military and medical applications. Wherever we need step-by-step movement, we can use this stepper motor. Now we'll see the advantages. The first advantage is no feedback is normally required for either position or speed control. We know that feedback is given in order to maintain the constant speed. In normal application, feedback will be given. We will continuously check the output speed. If it is greater or lesser, that this controller will modify the operation so that it will maintain the constant speed. But here this feedback is not required. So for example, in a printer, after every line there is a particular rotation of paper, that is a 15 degree, 16 degree, like that it will rotate. So feedback is not required. Automatically it will go to the next position. Positional error is not cumulative. So any position, one position is error mean that will not go to the next level. It will automatically move to the another position. So it's not cumulative, means it's not added. Stepper motors are compatible with digital equipments because this stepper motor operated by the pulses, train of pulses, already digital is available. It's not a continuous rotation motor, not a continuous supply. Digital signal is already given. So automatically we can compatible with the digital equipment. It requires less maintenance. There is no windage, friction, losses are not there. The losses are very less, so less maintenance is required. It is mechanically simple and free from contamination. Right? Mechanical structure is simple, contamination is not available. We'll see the types of the motor. So basically there are three types of motor available. Variable reluctance stepper motor. The rotation of rotor based on the reluctance, value of the reluctance. That's why called a variable reluctance stepper motor. Permanent magnet stepper motor. The rotor contains the permanent magnet. Hybrid, combination of these two is called a hybrid stepper motor. Separate video available for these three types. Construction, operation, all are separately available. Construction of these motors, operation of this motor, comparison, all the videos are separately available. Link is given in the description box. So in this video we discuss what is the stepper motor, what are the stepping angle, step angle, then definition, resolution, then frequency, the motor shaft speed, advantages, application, and various types of stepper motor. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. All the best for your examination.